These next few theorems have to do with different chords throughout the circle. So the first one we're going to talk about is if a diameter or radius is perpendicular to a chord, then it bisects the chord and the arc. So let's look at this picture. So I have a radius, and I see that it's perpendicular to this chord. So what that means is that this chord is going to be cut in half, and these two arcs are going to be congruent. Similarly to that, if we know that one chord is a perpendicular bisector of another chord, the first has to be a diameter or a radius. Because if it's a perpendicular bisector, like this situation, that happens when this is a diameter. So let's look at an example. We want to find ZY, which is this whole chord. We know that this is a radius, and so that means it's going to bisect this segment. It's also going to be perpendicular. So my best hint to you guys is to draw a right triangle here. So when I look at this, I'm going to draw a right triangle like this that goes from the center to the edge and then uses those two segments as my leg. So I'm just going to copy this over to here. So here's what we know. We know this height is 12. We know that's a right angle. We want to know something about this side because that's ZY. So I'm going to make that X. So I need to know the length of my hypotenuse. And the saving grace here is that that is a radius. And so if I look at this radius that I already have, which is 12 plus 28, I can tell you that this radius has to be 40 because those are the same. So now I can figure out at least from Z to that midpoint. So I'm going to do x squared plus 12 squared equals 40 squared. Because remember, my hypotenuse needs to be by itself. So x squared plus 144 equals 1600. And so that gives me that x is approximately 38.16. So that's just my distance here, 38.16. So to get zy, I would need to double that. 2 times 38.16, which would be 76.32 miles. So let's try another one. Let's look over here. So I know here that my radius is 4.7. So if I make this into a right triangle, my radius is going to be 4.7. So if I draw my triangle, this is 4, this is x, this is 4.7. So x squared plus 4 squared would equal 4.7 squared. So I get x squared plus 16 equals 22.09. So I'm going to subtract 16 from both sides. So I've got x squared equal to 6.09, square root both sides. So x is approximately 2.47. So that, again, is just this length right here. So if I want the length of EG, I'm going to have to double that. And so that's going to be 4.94 kilometers. So our last theorem here is another big one. If two chords are parallel, their intercepted arcs are congruent. So let's look at kind of an outline of what that proof would say. So if I'm given that these chords are parallel, then I would know that these two angles have to be congruent because they're alternate interior, right? So now think about what that means. This is an inscribed angle, which means that this arc is twice the angle. That's also true for this inscribed angle. So because these two angles are congruent and they're both inscribed, that means these two arcs would have to be congruent. So if I have parallel lines, their intercepted arcs are congruent. So let's look at what that looks like. So here's my parallel lines, and I'm going to go over my intercepted arcs in another color. Let's do those in purple. So CA is one of the arcs, DB is the other of the arcs. So because I know these are parallel, I know that CA is congruent to DB. So we need to figure out what that means. So I know that this whole half circle is 180 degrees. I know that this piece is 80, and each of these little pieces have to be the same. So what I know is that x plus 80 would have to equal 180 degrees. So 2x would have to equal 100, and so x here would have to be 50 degrees. So arc CA is 50 degrees.